Welcome to Power System Analysis using ETA. In this lecture, we are going to discuss optimal capacitor placement. Capacitor plays a very vital role in the industrial network. So let us see why it is necessary and why do we need this feature in ETAP for this capacitor placement. So most of the load in modern electrical distribution system are inductive. So the example of such a load is motor load, transformer, tube lighting, induction furnaces. So and what is the most important thing about this motor load? You know that in this motor load or inductive load, why this load is called inductive? Because anything which has magnetic field associated with it is known as an inductive load. So inductive load needs a magnetic field to operate. Now for inductive load to operate, we will have two kind of things. You have seen that when we were running this load flow analysis also, we had two values available, the active power and the reactive power. So what is this active power? The working power to perform the actual work of creating heat, light, motion, machine output and so on is known as active power. So which is calculated in megawatt or kilowatt. Whereas the reactive power, kilowatt or the megawatt, is to sustain this magnetic field. So the working power consumes watts and can be read on wattmeter. It is measured in kilowatts, megawatts, and reactive power doesn't do useful work, but circulates between the generator and the load. So basically it's a magnetic field which is continuously circulating between the generation and the load. It places a heavier drain on the power source as well as on the power sources distribution system. So reactive power is measured in kilowatts or kVAR or MVAR. So this is what we mean by. So how do we demonstrate or say this power in? So we use this term apparent power or the kVA power. That's why you have seen that these motor or these generators or these transformers, all these have this power in MVA or kVA or basically apparent power. It's not in megawatt. The reason is this, because each of this equipment have some inductive load associated with it. So when the power will flow through them, the adjustment, I'm not using any tolerance. So let us press OK. Now perform the optimal capacitor placement. Let us run and see if ETAP is able to solve or not. So once the case has solved, let us see that just in order to improve the capacitor, we require a huge amount of capacitor in this case. So you see that at tail end here at 13.8 kV location, I require 15. Here 8. So at each point I require some capacitor banks in order to improve. But if I provide these amount of capacitors in my system, then I can improve the power factor, and my power factor will not be dropped below 95% for the transmission system. So this way you can improve the capacitor. So you can calculate the requirement of capacitor. So if you want to see the results, seeing the result is simple. You will simply go to report manager. In this case, let us select result and OCP result. When I press OK, there my results are displayed. So in this case, my requirement is 75. So it's a huge requirement, but this was just the case to show you how you will require, and this will require a huge investment in the capacitor for just the two. But this was just a sample case to make use or make you show that how this capacitor placement optimization can be used. In the real world, this will be far less than this.